So today's lesson is going to be on the atom, and atoms are the smallest part of matter. Now, to be honest, that's really not the whole truth, but for the purpose of our class, we're going to assume that the atom is the smallest part of the matter. And the atom is made up of three subatomic particles. The protons, which we often abbreviate with a P or sometimes a P positive, superscript positive. Protons are positively charged. They have a mass of 1 AMU, atomic mass unit, and they are found in the nucleus of the atom. And we're going to talk about what that means and what that looks like here in a few minutes. The second subatomic particle is a neutron. Neutrons, we use an N or sometimes an N superscript 0. Neutrons are neutral, meaning they have no charge. They also have a mass of 1 AMU, atomic mass unit, as well as being found in the nucleus, just like a proton. All right, so what do we notice about protons and neutrons? They both have a mass of 1. They're both found in the nucleus. The difference here is protons have a positive charge. I remember that, P for proton, P for positive. Neutrons have no charge. They are neutral. And I remember that because the first 5 letters of neutron, N-E-U-T-R, is also the first 5 letters of neutral. The third subatomic particle is the electron. And we are going to abbreviate electrons with an E minus. Electrons have a negative charge. They have no mass. Now, again, this isn't 100% accurate when I say no mass. Electrons do have mass. The reality is their mass is so small that it is considered negligible. So that's why we say no mass. And they are going to orbit the nucleus in energy levels. So here on our notes, we have taken a few different terms here, and we want to figure out what they mean. So let's draw an atom. And we're going to draw carbon. So here's carbon. Carbon has, according to our periodic table, let's put this periodic table back up here, a 6 and a 12.01. So what does this mean? The 6 is what we call the atomic number. And the atomic number is the number of protons. The atomic number is important because let's take a look at our periodic table. Do we see any element on the periodic table that has an atomic number that is the same? And as we go through, we notice that none of our elements have the same atomic number. So what does that tell us? That tells us that the protons are the determining part. Protons determine the element. If I change the protons, aluminum has 13 protons. If I change the protons to 14, I no longer have aluminum, I have silicon. So the protons are very important there. The bottom number is the number of neutrons and protons that make up the atomic mass. So atomic mass, and that is protons and neutrons. So if this is protons and neutrons, and the atomic number is the protons, how could I find the number of neutrons within an atom? All right, and so we're going to simply have to do a subtraction. We know the protons, so we can subtract out the protons from the atomic mass, leaving us with just the neutrons. Now, for now, we are going to round using our nearest whole number. So 12.01 would round to 12. We're going to learn what that decimal means later on in another video. But for this particular unit and portion of our unit, we are rounding to the nearest whole number. Normal rounding rules apply. So for example, if we looked at number 31, gallium, 69.72. That 7 rounds the 69 to a 70. All right, normal rounding rules apply. So my atomic mass minus my atomic number equals, in this case, 6, and that's going to be my number of neutrons. Now, I know in carbon, based on the periodic table, and this is the most common type of carbon, I know it has 6 protons. I know it has 6 neutrons. Now, if it is a neutral atom, which for today's lesson, all atoms are neutral. We're going to have a whole nother lesson on how to determine if it is not neutral. So today, all atoms are neutral. So a neutral atom is going to have protons equaling the number of electrons. So if I have 6 protons, I also have 6 electrons. These two values are going to be the same because a proton is a positively charged. So if I have 6 protons, 6 positives, I drew one too many, let me take one off, and electrons are negative, I have 6 negatives. What does that do? A positive and a negative cancel out, making it neutral. Now, let's draw this atom. We're going to draw this atom, and I'm just going to show you. We're going to have a whole nother lesson, though, with a Bohr model. All right, and let's just look at our basic structure of the atom, and we're going to learn where all of this goes in another video. But our basic structure of the atom, protons and neutrons are going to go in the nucleus. That's the center of the atom. And then our electrons are going to circle the atom. Now, each one of these lines that I drew, these circles, each circle is an energy level. And that's a specific location, like a step. If you were standing on a step, it's a specific location where electrons are found. When we put energy levels together, we call that the electron cloud. So all the energy levels together is the electron cloud. So in this picture that I've drawn here, I have 2 energy levels making up the electron cloud. Now this brings us into our worksheet, all right, our subatomic particles worksheet. And let me just kind of fold that over so that we only have the information that we need for our notes. All right, so what are we going to do here? We are going to use the information in the chart. The atomic number is 15. 15 is phosphorus. So 15 is the number of protons. Protons will be the same as electrons for now because they are neutral atoms. And again, all atoms in today's lesson are neutral. P is phosphorus. All right, and our mass number. The mass number of phosphorus, according to the periodic table, is 30.97, so that rounds to 31. To find the number of neutrons, I am going to take the mass number, 31, and subtract out the number of protons, which is 15, to give me 16 neutrons. Boron. Boron has a symbol B. Here's boron on the periodic table. It has an atomic number of 5. So that is 5 protons. Protons equal electrons. Now my chart tells me the mass number of boron is 11. So 11 subtract out 5 is 6 neutrons. All right, let's look at our next example here. Selenium, and I even gave you the symbol Se. So selenium is here. It has an atomic number of 34. So that is our number of protons and electrons. The mass number of selenium is 78.96. So that is going to round to 79. 79 minus 34 is 45. So hopefully this is starting to make a little bit of sense. Be. Be is beryllium, and it has an atomic number of 4. The atomic number is the protons and electrons. To get our neutrons, 9 minus 4 gives me 5 neutrons. What has an atomic number of 7? The atomic number 7 is N for nitrogen. So my symbol is N, and this is nitrogen. Now the periodic table I'm using doesn't have the names, but your periodic table that I provided you on day 1 does have the names of the elements, so use that one. The atomic number is the number of protons and electrons. To find my number of neutrons, 14 minus 7 is 7. All right, number 6. I have 32 protons and 41 neutrons. So to work backwards, if the nucleus, the mass number is protons plus neutrons, I could just add those together. So 32 plus 41 gives me a mass number of 73. Protons is the electrons and the atomic number. What has an atomic number of 32? And we're going to check this out, and we see here that it is Ge, which should be germanium. All right, last example. A mass number of 14, we have 18 electrons. Well, we know it's neutral, so electrons equal protons. Protons is the atomic number, so 18. So what has an atomic number of 18? And that's going to be Ar, which is argon. To find the number of neutrons, I'm just going to do 40 minus 18, and that is 22.